From stones to steel, from castles to cannons, and from muskets to machines, this is the story of how warfare shaped our world. Witness the rise of empires, the fall of kingdoms, and the battles that changed history forever. Welcome to the Arsenal of History. The Cold War was a time of deep mistrust. It began after World War II, a conflict that had, really reshaped the entire planet. Two great powers emerged from the ashes of that war, the United States and the Soviet Union. They had been allies, but their fundamental beliefs about how society should work were honestly worlds apart. One championed capitalism and democracy, the other communism and state control. This ideological divide created a chasm between them. They never fought each other directly on a battlefield. Instead, they engaged in a long, tense standoff. This was the Cold War, a struggle for global influence fought with propaganda, proxy wars, and most terrifyingly, technology. The story of this technological race begins with a mushroom cloud. It begins with the atom. The United States ended World War II by dropping atomic bombs on Japan. These weapons unleashed a power never before seen in human history, the power locked inside the nucleus of an atom. Suddenly, the nature of warfare had changed forever. The Soviet Union, seeing this incredible destructive capability, knew it could not afford to be left behind. It had to possess this power as well. This realization ignited the nuclear arms race, a frantic competition to build bigger and more powerful bombs. It was a race driven by fear, a fear that the other side would gain an unbreakable advantage. The first Soviet atomic bomb test in 1949 shocked the world. It signaled that the American nuclear monopoly was over. The race had truly begun. In response, the United States pushed forward to create something even more devastating, the hydrogen bomb, or H-bomb. This was a thermonuclear weapon, hundreds of times more powerful than the atomic bombs that came before it. It used the fusion of atoms, the same process that powers our sun, to create an even greater explosion. The goal was no longer just to have a bomb, but to have the most terrifying bomb, to create a deterrent so powerful that the other side would never dare to attack. This was the logic of a new age. This relentless pursuit of nuclear superiority led to a terrifying concept known as mutually assured destruction, or MAD. Both the United States and the Soviet Union built vast arsenals of nuclear weapons. They had enough bombs to destroy each other many times over. This created a fragile, terrifying balance. If one side launched an attack, the other would retaliate with overwhelming force, ensuring the complete annihilation of both nations and possibly the world. The very weapons created to guarantee victory now guaranteed that a full-scale war could have no winner. This paradox, this balance of terror, defined the daily reality of the Cold War for decades. The nuclear bombs were the ultimate threat, but they needed a way to reach their targets. This need fueled another intense race, this one for control of the skies. The era of the propeller plane was ending. A new kind of aircraft was taking over, the jet. Jets could fly faster, higher, and farther than any plane before them. They were the perfect delivery system for the new atomic arsenal. The United States developed bombers like the B-52 Stratofortress, a massive plane designed to fly deep into Soviet territory. The Soviet Union answered with its own long-range bombers, like the Tupolev Tu-95. The skies became a potential new frontline in this global standoff. Fighter jets were just as crucial. They were needed to protect the bombers and to shoot down enemy aircraft. This led to rapid advancements in aviation technology. The Korean War in the early 1950s became a testing ground for these new machines. American F-86 Sabres dueled with Soviet-made MiG-15 jets in the world's first large-scale jet versus jet combat. Each side studied the other's technology, looking for weaknesses and ways to improve. The designs evolved quickly. Engineers pushed the limits of speed, creating planes that could break the sound barrier. Every new model was a statement, a demonstration of technological prowess aimed at intimidating the opponent. But even jets had their limits. They could be shot down. A more reliable delivery system was needed, one that was nearly impossible to stop. The answer was the missile. Both superpowers poured enormous resources into developing ballistic missiles. These were rockets that could travel thousands of miles, soaring high above the atmosphere before delivering their nuclear warheads with terrifying precision. The United States developed the Atlas and Titan missiles. The Soviet Union created the R-7, the same rocket family that would later launch the first satellite. These missiles reduced the warning time for an attack from hours to mere minutes. The development of intercontinental ballistic missiles, or ICBMs, changed the strategic landscape completely. Now, a nuclear attack could be launched from a silo deep within one country and strike a city on the other side of the planet in under 30 minutes. The threat was no longer distant, it was immediate and ever-present. To make matters worse, submarines were eventually equipped with nuclear missiles. This meant a devastating strike could come from anywhere in the world's oceans, creating a truly global web of threat. The arms race was no longer just about having the biggest bomb, it was about having the fastest and most unstoppable way to deliver it. The same rocket technology that powered ICBMs had another, more hopeful application. It could lift us beyond our own world. It could take us to space. But in the context of the Cold War, even the exploration of the cosmos became another arena for competition. The race to space was deeply intertwined with the arms race. Mastery of space demonstrated technological superiority. It also had significant military implications. The nation that controlled the high ground of space could potentially hold a decisive advantage on Earth. It was a new frontier for both scientific wonder and military strategy. The space race began with a beep. In 1957, the Soviet Union launched Sputnik 1, the first artificial satellite to orbit the Earth. This small, polished sphere sent a simple radio signal back to us, but its message was profound. It announced to the world that the Soviets had taken the lead in space technology. For the United States, this was a stunning blow, a Sputnik moment that sparked a national crisis of confidence. If the Soviets could put a satellite in orbit, they could certainly send a nuclear warhead to any city in America. The fear was palpable, and it spurred the United States to accelerate its own space and science programs. The competition escalated quickly. The Soviets sent the first animal, the dog Laika, into orbit, and then the first human, Yuri Gagarin. Each achievement was a victory in the ideological struggle, showcased to the world as proof of the superiority of the communist system. The United States responded by creating NASA and setting an audacious goal to land a man on the moon before the end of the decade. The Apollo program was not just a scientific endeavor, it was a national mission, a direct answer to the Soviet challenge. The race to the moon captivated the world, a dramatic saga of human ingenuity fueled by geopolitical rivalry. While the world watched the astronauts and cosmonauts, another more secret space race was underway. Both sides launched fleets of spy satellites. These eyes in the sky could photograph military bases, missile silos, and troop movements deep inside enemy territory. They provided crucial intelligence that was impossible to gather otherwise. Space also became essential for communication and navigation. Satellites could relay military commands and eventually guide missiles to their targets with incredible accuracy. The peaceful expanse of space was being militarized, becoming an integrated part of the global war machine, a silent and invisible battlefield. The relentless technological race during the Cold War had a profound and lasting effect on the world. It created a state of constant, simmering tension. For nearly half a century, humanity lived under the shadow of nuclear annihilation. School children practiced duck and cover drills, a futile gesture against the power of the atom. The Cuban Missile Crisis in 1962 brought the world to the very brink of nuclear war, a moment when the fate of civilization hung by a thread. This pervasive fear shaped politics, culture, and the daily lives of billions of people. The arms race was a primary driver of this anxiety, a constant reminder of how close we were to catastrophe. However, the legacy is not entirely dark. This intense competition also spurred an unprecedented wave of scientific and technological innovation. The drive to win the space race led to countless spin-off technologies that we now use every day. Things like GPS, memory foam, and even the computer mouse have their roots in this era of accelerated research. The massive government investment in science and education, particularly in the United States after Sputnik, created a generation of engineers and scientists. The internet itself began as a military project, ARPANET, designed to create a decentralized communication network that could survive a nuclear attack. When the Soviet Union collapsed in 1991, the Cold War ended. The immediate threat of a global nuclear war between two superpowers receded, yet the weapons did not disappear. the world was left with vast stockpiles of nuclear bombs and the knowledge of how to build them. The challenge shifted from a two-sided standoff to the complex problem of nuclear proliferation, preventing these incredibly dangerous weapons from falling into more hands. The technologies of the Cold War, from missile guidance systems to nuclear materials, became a new source of global instability in a world that was no longer so clearly divided into two camps. Ultimately, the Cold War's technological race was a story of duality. It pushed humanity to the edge of self-destruction, while simultaneously propelling us forward into a new age of discovery. It taught us a terrible lesson about the dangers of unchecked rivalry and the terrifying power that science can unleash. But it also showed us what we are capable of achieving when we are driven by a great purpose, even one born of conflict. From the atomic nucleus to the orbits of distant planets, this race forever altered our relationship with technology, our planet, and our place in the cosmos. It's a legacy we still live with today, a reminder of our capacity for both brilliant creation and utter destruction.